Okay, girls, we're looking at, for those that aren't here, we're doing this worksheet, exercise, they're from Mathscape. And they're harder problems from your Year 10 textbook. We're down to some questions from exercise 3.4 on surface area of a cone and sphere. And the question that we're going to look at is exercise 3.4, question 13. A cone has, so I'm going to draw the cone. It's got a slant height of 6 centimeters. And we know that the surface area of the cone is 40 pi. Find the radius. What should you do? So you know that the surface area of the whole cone is 40 pi. But the surface area of a cone, the formula is, what is it? Pi r squared plus pi r, s or l? L. It's either pi r squared plus pi rl or pi r squared plus pi rs. I can't remember what I gave you in the formula, if the slant height was s or l. All right. So this is the L is 6, but we don't know what the radius is, and we have to find the radius. So what will I do next?
40 pi.
Yeah, I know that the surface area is 40 pi, so I put that in there. Oh, I know why you can't do this. Because it's a quadratic and you haven't learned how to do them. Plus, what's the L, girls?
6.
So we've got pi times r times 6. So I've got 40 pi is pi r squared plus 6 pi r. Now, girls, you can't do this. You haven't learned how to do quadratic equations. So we're not going to do it. Who does know how to solve quadratic equations? How to factorize x squared type equations? No, I cannot ask you something like this in the exam until next year. So I didn't realize that this would be a quadratic. Girls, do you know how I could simplify this? But what does each term seem to have? So I'm going to divide through by pi. You know, if you've got a balanced equation, you can divide both sides by something. So I'm dividing this side by pi. What do I get? Now, when I divide this side by pi, I'm dividing both of them by pi. So divide that by pi and I get r squared. Divide this by pi and I get 6r. Now, you know what we might do? You haven't learned how to solve the quadratic. Do you want to just take a bit of a guess? Try if, say, r is 3 or something. What would you get? What would you get if r was 3? We're just going to do it by guessing. 9 plus 18, that's not 40. What about if r is 4? Let's guess. So, at this stage in Year 9, we haven't learned how to solve this. The question doesn't say that the radius is to 1 decimal place. It's going to be a whole number. You will not get a question in an exam like this, but I'm just going to guess. We're going to do some guessing for r because you'll learn later how to solve this by factorizing, but you don't learn it till next year or a bit later this year. So I'm just going to guess. So let's try r is 3. What do you get? 40 is 3 squared plus 6 times 3. Does that equal? Does that work? 9 plus 18 is? That's incorrect. Try r is 4. Do you see what I'm doing? 40 is 4 squared plus 6 times 4. 40 is, what's 4 squared? 16 plus 24. So what's r? Therefore, r is 4. Now, when you learn how to solve quadratic equations, you won't do it like that. What we do in Year 10, we take this and we bring the 40 over to this side and we get r squared plus 6r minus 40 is 0. Anyone seen this before? But you will learn it later this year. You'll learn how to factorize this. I'm just showing you for anyone that's learnt it. You get r plus 10, r minus 4. We're going to learn this later. And then we're going to get r is 4 or minus 10, therefore r is 4. Don't worry about it. You don't have to know how to do it, but we're learning it later. At the moment, we'd guess it, and at the moment, I'm not allowed to give it to you. So, there. So don't worry about the question. A solid sphere. That's like a tennis ball. Not that that's really solid. It's like a big, round, solid Easter egg. Is cut, not a hollow one, a solid one. So a solid sphere is cut in half. Find in simplest form the ratio of the surface area of the hemisphere to the surface area of the sphere. Don't even worry that it says the ratio of. I would just work out the surface area of the hemisphere and the surface area of the sphere, and then ratio, you put that ... the other one. So don't worry that it says ratio. If you ever get questions that say find the ratio of this to that, or the percentage that this is of that, don't worry that it says ratio or percentage. Just find the surface area of the hemisphere, find the surface area of the sphere, and then work out what to do after that. So, girls, here is my solid sphere. It's solid. And then it's going to be cut in half. So when it's cut in half, that's the hemisphere. So that's the solid sphere. It's solid. Radius r. That's my sphere. This is my hemisphere, means half a sphere, you know, the northern hemisphere and the southern hemisphere. A solid sphere is cut in half. Find in simplest form the ratio of the surface area of the hemisphere, that's this one, to the surface area of the sphere. All right, do you want to do the sphere first? What's the formula for surface area of a sphere? Good. So that's the surface area of a sphere. Good. Now the hemisphere, girls, when you're doing surface area, just look at all the different surfaces that you need to work out. The hemisphere is this, which is what? 4 pi r squared is the whole circle, so it's going to be 4 pi r squared divided by 2 plus, I got the circle on the top. So you've got the curved bit and you've got the top. Plus, I've got this bit. I've got two surfaces. The curved bit down the bottom, half of the sphere, and the circle on top, plus pi r squared. So therefore, what's 4 pi r squared divided by 2? 2 pi r squared. 4 over 2 is 2. So it's 2 pi r squared plus pi r squared, which is 3 pi r squared. So we're nearly done. So therefore, the ratio of the surface area of the hemisphere, so I'm just going to go surface area of the hemisphere, ratio means ... surface area of the sphere equals. So the ratio of, you know, you write ratios as either something over something or something colon ... something else. So what's the surface area of the hemisphere equal to? 3 pi r squared to, what's the sphere? 4 pi r squared. See, girls, when you simplify ratios, if I want to simplify the ratio 5 to 10, how do I do it? I divide both sides by whatever I can, and I get 1 to 2. What can I divide both sides by here? What's identical on both sides of the colon? I divide both by pi r squared, and I get 3 to 4. Do you see that? So I divide both sides by pi r squared, because there's a pi r squared in both of them. And the pi r squareds cancel, and I get that the ratio is 3 to 4. So girls, you've got to break the question down. Don't even think about ratio. Just pick the words. I need the surface area of the sphere. I need the surface area of the hemisphere. If this is worth 3, if you can just give me surface area of sphere and surface area of hemisphere, that's 2 out of 3. Then you worry about your ratio or your percentage or whatever in the end. All right? Here in this question, we've got a hemisphere of radius 10 centimeters. And from that, a hemisphere of radius 7 centimeters is cut out of it. No, the top, yes, it will be open on the inside. Does anyone have, so just think of it as a really, so the distance from there to there is 10. And the distance for the smaller bowl inside that's been carved out, The radius of that one is 7. So you've actually got 3 surfaces that you will be able to see. The outside of the bowl. So you've got the outside of the bowl, which has got a radius of 10. That's all around the outside. Then we can also see the inside of the bowl, which has a radius of 7. Plus, if you stand over the bowl, you will see an annulus. This is the top view of the bowl, looking down at the bowl. You'll see the rim of the bowl. That's the rim. And what you'll see is the shaded bit. So you've got 3 basic surface areas that you've got to work out and add together. 3 areas. So, do you know what to do? How do you work out this hemisphere? Surface area is, what's the formula for that one? 4 pi r squared over 2. Now, isn't that just 2 pi r squared? So it's 2 pi times, what's the radius of that one? And what's that? Don't work them out. Just give it in terms of pi. You okay? 1, yes? No, I'm doing the outside of this bowl. Let me try and get a picture. Those of you that may not be here, you've got the inside of the bowl, radius 7. I know this is not to scale. You've got this outside of the bowl, and then you've got the rim, which is an annulus. Okay, so you've got 3 surfaces that you have to work out. Okay, let's keep going. So outside of the bowl, 4 pi r squared divided by 2. 2 pi r squared, which is 200 pi. 4 pi r squared over 2, which is 2 pi r squared, 2 pi times 7 squared. 49 times 2, 98 pi. The top of the bowl area, I'm just going to put area, is what? Big circle minus little one. Pi r squared minus pi r squared. In other words, big circle minus little one. Pi times 10 squared is the big circle. Cut out the little one and you're left with the rim. Minus pi times 7 squared. What's that? 100 pi minus 49 pi is 51 pi. So therefore, I have 3 surfaces that I add together as you saw in the bowl. Oh, here, outside, inside, the top. Look here, the rim. That's an annulus. It's big circle minus small circle. If I want to form that shape, I would cut out a solid circle and I'd cut a circle out inside it and pull it out. So therefore, the surface area of the bowl is, of the solid, what is it? Do you get it? 200 pi plus 98 pi plus the rim on top, 51 pi, which is, what is it, 300 and pi centimeters squared because it's surface area. A cone has the same radius and surface area as a sphere. All right. Shh. I'm drawing it. Shh. So, a cone has the same radius and that cone has the same surface area as this sphere. Girls, so I know that you are flabbergasted with this question more than likely, all right? But to start, you would draw it, and I'd actually have the drawing for you in an exam. So a cone has the same radius and surface area as a sphere. So both the cone and the sphere have the same radius, but they also have the same surface area. So let me write down the formula for surface area of each, and when I've written that down, I can put that they equal each other. That's what it means. The cone and the sphere have the same radius, but they also have the same surface area. All right, we don't know what that is. Let's write down the formulas. What's the formula for surface area of a cone? Good. What's the formula for surface area of a sphere? Now, because these surface areas, SAs, are the same, so the surface areas are the same, therefore I can say that 4 pi r squared equals pi r squared plus pi rl. So I can say that this equals that. I just like to have the bigger one on the left. Doesn't matter which way I wrote it. Does this make sense? So I drew each. They've got equal radii. I've written down the formula for the surface area of each, and the surface areas are the same. All right, we're nearly there. We are almost there. Can you see any like terms? That means all pronumerals and pi's must be the same. And 4 pi r squared. So can I do 4 pi r squared minus pi r squared is pi rl? Do you see that? That's 4 lots of pi r squared equals 1 pi r squared. They're like terms. So take this one to the left. Are we good with that? So what's 4 pi r squared minus pi r squared? 4 pi r squared minus 1 pi r squared. Yeah, it's like 4x minus 3x. It's like 4 of those minus 1 of those. A pi r squared is a thing. 4 of those minus 1 of those. If I put 4x minus 1x, you tell me it was 3x. 4 lots of pi r squared minus 1 lot of pi r squared is 3 lots of pi r squared. Now all we're going to do now, you okay with that? Girls, I like to compare both sides. What's the same? So the pi is exactly the same. So I can divide by pi, 3r squared. So if I say the pi's are the same, doesn't it mean that the 3r squared equals the RL? That's what I'm doing. I'm saying those two are the same, the pi's are the same, so the 3r squared must equal the RL. What else is the same? One of the r's is the same as that, so 3r equals L. We're done. L, the slant height, equals 3 times the radius. So how did I go from there to there? I divided both sides by pi. You can just make L the subject of the formula, actually. That's easier. Thank you. All right, you know what we'll do? All right, if this is, just copy this for now, and then I'll show you another way. Divide both sides by R. Or I just compare from line to line. That's what I do. I say the pi's are the same, so 3r squared is RL. That's 3RR, RL. The r's are the same, so 3r equals L. Or, this is the other way. Sorry. This is the other way to do it. 3 pi r squared equals pi RL. Oh, squared. Sorry to the people there. I forgot to record. But we got to this stage here. You can either divide, because the pi's are the same, 3r squared must equal RL. Because there's an r here and an r there, you can divide both by r and you'll get 3r equals L. The other way of doing it, 3 pi r squared equals pi RL, is to divide by pi r and cancel, and you'll get that 3r equals L. Question. What's the question? A sphere fits tightly into a cylinder as shown. Show that the ratio, so I'm going to draw the cylinder and the sphere separately because there's something special about it. Girls, that's the radius of the sphere. It says show that the ratio of the surface area of the sphere to the surface area of the cylinder. So don't worry about ratio. Just give me the surface area of the sphere and give me the surface area of the cylinder. But I better put them the other way around. I'll draw the sphere first and then the cylinder. Because we want sphere dot dot cylinder. Ratio of surface area. I need sphere first and then cylinder. Now, girls, the radius of this is that. What's the surface area of that? Anyone? Surface area of the sphere. R squared. All right, girls, what's that distance? Is this R because it fits straight in? Tell me what the height is. What height is that? I know it's H, but there's something special about H. No? Girls, what? Yeah, it's the diameter, which is? So girls, the height is actually R plus? No. R plus R. H is? Yeah, it's the, which is 2R. Isn't the height 2 times R? That's it. So girls, surface area of the sphere we know is 4 pi R squared. Here's the cylinder. What's the formula for surface area of a cylinder? No, it's only because, girls, the height's not always 2 times the radius, but in this particular case, because the sphere fits exactly in, that distance there is R, so's that one up there, and so's this one down here. Can you see what I'm doing? So therefore the height is 2R. Now the reason I had to get rid of H, I can't compare R's with R's and H's. I needed to get rid of the H. You'll see why in a minute. So what's the normal formula for surface area of a cylinder? Plus 2 pi R H. Now you can't compare those two because of the H. So it's really 2 pi R squared. No, that is the surface area of a cylinder. 2 pi R squared is the 2 circles, and the curved bit is 2 pi R H. I don't know what Sir taught you that lesson. 2 pi R squared is the 2 circles, 2 pi R H is the curved bit. So, 2 pi R times, what's H? Shh. So it's 2 pi R squared plus, what's that times that? 2 pi R times 2R is 4 pi R squared, good. What's 2 pi R squared plus 4 pi R squared? Good, because it's 2 of those plus 4 of those. So now, the ratio of the sphere to the cylinder is, what's the sphere? 4 pi R squared. The cylinder is 6 pi R squared. What can you automatically, what's identical on both sides that can go? So it's 4 to 6. Simplify 4 to 6. Divide them by 2. Done. So girls, listen, with these, you just write the formulas for each. The trick here is to know that, the trick here was to know that the R and the R made the H. And if you couldn't get that, then you'd be stuck. Do you understand? Because you can't compare this side with that side while that H is there. You needed to make this all into one thing. But because the H is 2 lots of the R, as in that diagram up there, or here, because the height of the cylinder is an R and another R, because whenever they ask questions about tennis balls sitting inside of, 3 tennis balls in a pack, stuff like that, you've got to do that. R, 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 R. Keep going. Okay, girls? Then it's all in terms of R. And now you can do the ratio.